Ever pondered how digital devices interact with each other? It's a question that invites us into the captivating world of digital communication. In this realm, data is transferred in binary form, using a language of ones and zeros that our devices understand perfectly. As we delve deeper, we'll encounter two essential components of this language: open collector/open drain and tri-state logic. These terms might sound intimidating, but they are actually quite straightforward. They refer to different methods of communication used by digital devices, each with its own unique characteristics and applications. Understanding these methods is crucial, especially for those who work with digital electronics, as they form the backbone of our interconnected digital world. From bus systems and interrupt lines to microprocessors and memory devices, these communication methods play a pivotal role in our everyday technology. So, buckle up and prepare to embark on an enlightening journey into the heart of digital device communication. It's time to unravel the mystery of digital communication. Dive into the world of open collector and open drain logic. In the realm of digital electronics, we often come across terms like open collector or open drain outputs. But what exactly do they mean? Simply put, an open collector, for bipolar devices, or open drain, for CMOS devices, output is a configuration where the output transistor's collector or drain isn't connected to a voltage source. Instead, it is left open and can be connected to either ground, representing a logic 0, or left unconnected, representing a logic 1. The key characteristics of this type of output include the use of a pull-up resistor and the ability to perform wired OR operations. To achieve a complete logic level, we often connect an external pull-up resistor between the output and the power supply voltage. This resistor ensures that when no device is driving the signal line, it is pulled up to a high logic level. When it comes to wired OR operations, multiple open collector or open drain outputs can be connected together on the same signal line. This configuration means that the line is pulled low if any device pulls it low, creating a wired OR logic operation. Now, you might be wondering, where do we use these open collector or open drain outputs? Well, they find extensive application in bus systems, where multiple devices share the same communication line. They're also used in microcontroller designs for interrupt lines, allowing multiple devices to request attention by pulling the line low. And if you've heard of the I2C communication protocol, it uses open drain outputs for bidirectional communication between devices. So, in essence, open collector and open drain logic provide a simple yet effective way for multiple devices to communicate over a shared line, whether it's a bus system or an interrupt line. They offer a level of flexibility that allows devices to either actively drive the line or passively let it be pulled up to a high logic level. So, that's the essence of open collector and open drain logic. Next on the agenda, tri-state logic. This is a fascinating aspect of digital electronics where an output can assume one of three states, rather than the typical two. These states are logic 0, logic 1, or high impedance, often abbreviated to high Z. This high Z state effectively disconnects the output from the circuit, allowing other devices to control the bus or line. It's a bit like being a wallflower at a party, stepping aside and allowing others to take the lead. Now, what sets tri-state logic apart is its use of an additional control input. This is often named enable, or OE for output enable. This control input is like a switch, allowing the output to be either active, that is, representing a logic 0 or 1, or in a high impedance state. When the output is in this high Z state, it's as if it's taken a step back, allowing other devices to have their say on the bus or line. Tri-state logic really shines in bus systems, where multiple devices share the same communication lines. Imagine a roundtable discussion where everyone has something to say. Now, without some form of order, this discussion would quickly turn into a chaotic cacophony. But with tri-state logic, each device knows when to speak and when to listen. When a device is not actively transmitting data, it places its output in the high impedance state, effectively stepping away from the discussion and giving others the floor. But the applications of tri-state logic don't stop at bus systems. It has a wide range of uses in digital electronics. For instance, tri-state buffers are commonly used to avoid bus contention. This is where more than one device tries to drive the bus at the same time, leading to conflicts. With tri-state logic, only one device actively drives the bus at any given time, allowing for smooth and conflict-free communication. Tri-state buffers also find their way into memory devices. Here, they allow multiple devices to share the same data lines without interfering with each other. It's like having multiple speakers connected to the same audio source, each playing their part without drowning out the others. Moreover, tri-state buffers are employed in microprocessor designs for address and data buses. They facilitate efficient bus sharing, allowing for faster and more efficient data transfer. It's as if each device on the bus has its own traffic controller, ensuring that data flows smoothly and efficiently, without any collisions. So there you have it. That's tri-state logic, a vital cog in the wheel of digital communication. Now, let's weigh open collector/open drain logic against tri-state logic. Let's begin with the output states. Open collector/open drain logic has two output states. When it's not connected to a voltage source, it represents a logic 1, and when it's connected to the ground, it signifies a logic 0. On the other hand, tri-state logic has three output states: logic 0, logic 1, and a high impedance state, which essentially disconnects the output from the circuit. Next, let's consider the wired OR operation versus tri-state. Open collector/open drain logic is often associated with a wired OR operation, where multiple devices can pull a single line low. This is useful in situations where any device can trigger an event. Tri-state logic, however, is designed for efficient bus sharing. When a device isn't transmitting data, it puts its output in the high impedance state, freeing the line for other devices to use. The requirement of a pull-up resistor is another point of difference. Open collector/open drain logic requires an external pull-up resistor to achieve a complete logic level. This resistor is connected between the output and the power supply voltage. Tri-state logic, on the other hand, typically doesn't require a pull-up resistor for complete logic levels, as it can actively drive the line to both high and low states. Finally, let's talk about the presence of a control input. In tri-state logic, there's an explicit control input often named enable or OE for output enable. This control input allows the output to be either active, representing a logic 1 or 0, or in a high impedance state. Open collector/open drain logic lacks this feature. So in a nutshell, while both open collector/open drain logic and tri-state logic have their unique strengths and applications, the choice between the two often depends on the specific requirements of your digital communication system. That's how open collector/open drain logic and tri-state logic stack up against each other. Time to wrap up our exploration of digital device communication. We've learned that open collector or open drain logic is a configuration where the output transistor's collector or drain isn't connected to a voltage source. This allows for a wired OR operation, where multiple devices can pull a signal line low. It's a valuable tool in bus systems, microcontroller designs, and I2C communication. On the other hand, tri-state logic gives us three output states: logic 0, logic 1, or high impedance, which disconnects the output from the circuit. This is particularly useful when multiple devices are sharing the same communication lines. You'll see it at work in memory devices and microprocessor designs. In comparison, while both open collector/open drain and tri-state logic are integral to digital device communication, they each have their unique characteristics and applications. The next time you use a digital device, remember the secret language it uses to communicate.